Once again, welcome to my viewers. Today we will discuss the properties of real numbers. We have already discussed that the numbers which can be expressed in the form p by q, where p and q are integers and p and q are co-prime, q not equal to 0, and these type of numbers are called rational numbers. Now p and q are integers, p and q are also co-prime. What does we mean by co-prime? Means p and q are not divisible by any other number other than 1. That means the fraction p by q is in the lowest term. Say for example 3 by 4. This fraction you see, both numerator and denominator, they are not divisible by any other number other than 1. That means it is in the lowest term, right? And the numbers which cannot be expressed in the form p by q, we call them irrational numbers. Let's say you denote these numbers by p, and rational numbers you denote by q. Now we know that every natural number is a whole number. Means natural numbers together with 0 are called whole numbers. So we see the natural numbers are inside the circle of whole numbers. Again, the whole numbers together with negative numbers are called integers. So you find all the whole numbers inside the integers. Again, every integer is a rational number. Any integer you can express in the form p by q. Even 0 can be expressed in the form 0 by, say for example 1 in p by q, where q not equal to 0. Denominator is non-zero integer. So every integer is a rational number. So you see the integers are inside the circle of rational numbers. Now rational and irrational numbers are together called real numbers. So we find within the real number, the universe, within the universe of real number, you find rational and irrational numbers, right? Now let's discuss a few more properties of real numbers. Say for example, if a number is not a perfect square, then its square root is irrational. Now the numbers like 1, 4, 25, 36, 49, etc. are called perfect square. These are called perfect square. Now you see, square root of 1 is either 1 plus 1 or minus 1. That means square root of 1 is an integer, and that means it is a rational number. Similarly, square root of 4 equal to plus minus 2. That means plus 2 or minus 2. So it's also an integer. These are integers. So square root of 4 is a rational numbers. Similarly, square root of 9 equal to plus minus 3. So if a number is a perfect square, then its square roots are called rational numbers. Now think about this, square root of 2. Now square root of 2 is not a number 2 is not a perfect square, therefore square root of 2 is irrational. Similarly, square root of 3, square root of 5, square root of 7, square root of 10, etc. are irrational numbers. Irrational. So if you find a number is a perfect square, then the square root of those numbers are rational numbers. But if you find a number is not a perfect square, then its square root is also irrational. Similarly, if a number is not a perfect cube, then its cube root is irrational. Now you see, what is perfect cube? Say for example, cube root of 8. Cube root of 8 means cube root of 2 into 2 into 2. That means 2 to the power 3 whole to the power 1 by 3. This 2 is a whole number, means it's a rational number. Cube root of 8 is rational. That means 8 is a perfect cube because we got a whole number or an integer, right? Similarly, cube root of 27, that means 27 to the power 1 by 3. 27 means 3 cube to the power 1 by 3. 3 to the power 3 multiplied by 1 by 3, 3. So 27 is a perfect cube. So cube root of 27 is a rational number. Now think about this number, cube root of 10, that means 10 to the power 1 by 3. Now 10 to the power 1 by 3 is not a 10 is not a perfect cube, so we cannot find a number so that it can be expressed as a cube root of 10. That means cube root of 10 is irrational, right? Similarly, cube root of say 20 to the power 1 by 3, irrational, right? So if a number is not a perfect cube, that means 20 is not a perfect cube. You cannot find 3 identical numbers so that their product is 20. As for example, in case of 27, you find if you multiply 3 times, you got 27. That means 27 is perfect cube. If you multiply 2 3 times, you got 8. 8 is a perfect cube. Since 20 is not a perfect cube, so cube root of 20 is also irrational. Now let's discuss some more properties of irrational numbers. Closure property. Closure property. This property we have earlier discussed in case of whole numbers, integers. Closure property. You see, sum of two rational numbers, if a and b are rational, a plus b is rational. Similarly, if a and b are rational numbers, a minus b is rational, right? Means if sum of any two rational numbers is rational and difference of any two rational numbers is also rational, that means rational numbers are closed with respect to the operation of addition and subtraction. Similarly, product of two rational numbers is rational, right? Product of two rational numbers is rational. Now what about quotient of two rational numbers? A by b may not be a rational. A by b may not be a rational number. For example, say 3 and 0, these are rational numbers. Now 3 by 0 is not rational. In the definition of rational number, we find that rational number can be expressed in the form p by q, where q not equal to 0. That means the denominator should be a non-zero integer. Now it's 0. 3 by 0 is not defined actually. 3 by 0 is not rational number, so we come to know that quotient of two rational numbers may not be a rational number. Now think about another property. Rational plus irrational is irrational. Rational number, say for example 2 is rational, right? 2 is rational. Now think about this number. 2 is rational, 0.01001, 0001, 00001, etc. is irrational, right? It is non-terminating, non-repeating decimal. Now you find this sum of these two numbers. If you find sum of these two numbers, 0.01, 001, 0001, etc., then you find that 2.01, 001, 0001, this is irrational. So you find that rational number plus irrational number is irrational, right? Similarly, say for example 3 is rational, square root of 3 is irrational, so this is irrational. Sum of a rational number and irrational number is irrational. Similarly, rational multiplied by irrational number is irrational. Say for example 2 is a rational number, square root of 2 is irrational number. So 2 multiplied by square root of 2, 2 root 2 is irrational, right? Similarly, say for example 3 is rational and this number 2.10110111, etc. Now you see this is rational, this is irrational. Now find their product. You find that this becomes 6.60, 660, 6660, then 4 times 6, 0. This is irrational number, non-terminating, non-repeating, right? So product of a rational number and irrational number is also irrational. Now think about third case. Irrational multiplied by irrational may not be an irrational numbers. Say for example, you see square root of 2, this is irrational number. Now you multiply again this square root of 2, this is again irrational number. Now square root of 2 to the 4, square root of 4 is 2, this is rational. So irrational multiplied by irrational may not be an irrational. Sometimes it may be irrational. Say for example 2 multiplied by irrational multiplied by root 2 multiplied by root over 3, then this becomes root over 6. Now since 6 is not a perfect square, therefore square root of 6 is irrational. So irrational multiplied by irrational, this is irrational. But here irrational multiplied by irrational number is rational numbers. So our conclusion is irrational number multiplied by irrational may not be irrational always, right? Next property will say discuss commutative property. Commutative property, earlier we discussed if A and B are rational. A and B are rational number. If A and B are rational numbers, then you find that A plus B equal to B plus A, right? Commutativity property. Commutativity. Similarly, A product B equal to B multiplied by A, same. But A minus B may not be equal to B minus A until and unless B equal to A. If A and B are equal, in that case it is true. But if A and B are not equal, then in that case you see A minus B not equal to B minus A, right? So in case of the operation of subtraction, the commutativity is not followed by rational numbers, right? Similarly, A divided by B may not be equal to B divided by A. For example, 3 divided by 4 not equal to 4 divided by 3, right? Next, associativity. Say for example, A, B, C are rational numbers or real numbers. Then A plus B plus C equal to A plus B plus C, right? Say for example, half plus 2 by 3 plus 3 by 4, this equal to 1 by 2 plus 2 by 3 plus 3 by 4, right? This is called associativity. You can prove this. Find the sum of these two at first. Let's do the sum there first. Find their sum. LCM is 12. 3 4 are 12, 4 2 are 8, 4 3 are 12, 3 3 are 9, half. That means half plus 17 by 12. Again this LCM is 12. 2 6 are 12, 6 1 are 6. That means 23 by 12. Now you try to find the right hand side. Find the sum of the numbers within the parentheses. LCM is 6, right? Now 2 3 are 6, 3 1 are 3, 3 2 are 6, 2 2 are 4, plus 3 by 4, 7 by 6 plus 3 by 4. LCM is 12. 6 2 are 12, 2 7 are 14, 4 3 are 12, 3 3 are 9. Now 14 plus 9, 23 by 12. So you got the same result, 23 by 12. The associativity is followed by rational numbers. The same will be followed by real numbers also. Now let's discuss distributive property. A multiplied by B plus C equal to A multiplied by B plus A multiplied by C. Now let us prove with this same example. 1 by 2 multiplied by 2 by 3 plus 3 by 4. Now half multiplied by, first find the sum of the numbers within the parentheses. We already find this 17 by 12. This becomes 24, 17 by 24. Now try to find the right hand side. 1 by 2 multiplied by 2 by 3, A multiplied by B plus A multiplied by C. Now this becomes 6, 2 by 6 plus this becomes 8, 3 by 8. So LCM is 24. 6 4 are 24, 4 2 are 8, 8 3 are 24, 3 3 are 9. So this becomes 17 by 24. So you find that left hand side and right hand sides are equal. So distributive property is followed by rational numbers. Now another property, this we have discussed in case of integers. Every integer except 0 has an additive inverse. Say for example 3, additive inverse of 3 is minus 3, or additive inverse of minus 3 is plus 3. Similarly, additive inverse of minus 7 is 7, vice versa. Now same case is applicable for real numbers or rational numbers also. For example, additive inverse of 3 by 4 is minus 3 by 4. On the number line, if you can locate 3 by 4, then you can also locate minus 3 by 4 also. Similarly, additive inverse of 3 by 9 or 1 by 3 is minus 1 by 3, right? Additive identity element, any real number, a plus 0 equal to a. 3 by 4 plus 0 equal to 3 by 4. minus 5 by 7 plus 0 equal to minus 5 by 7. So 0 is called additive identity element. Multiplicative identity element. Any real number or rational number, say for example a multiplied by 1 equal to a. 1 is called multiplicative identity. 3 by 4 multiplied by 1 means 3 by 4. Minus 5 by 7 multiplied by 1 equal to minus 5 by 7. 0 multiplied by 1 equal to 0. Means multiplication with 1 will not change the identity of the element. That is why 1 is called multiplicative identity element. Multiplicative inverse. Now think about rational number 3 by 4. Now there is another rational number 4 by 3, so that 3 by 4 into 4 by 3 equal to 1. Now 3 by 4 is called multiplicative inverse of 4 by 3. This is inverse of this. Inverse means just you change the numerator into denominator and denominator into numerator. Similarly, multiplicative inverse of minus 1 by 3 is minus 3, because minus 1 by 3 into minus 3, answer is 1. So multiplicative inverse of minus 3 is 1 minus 1 by 3. Now does it exist for all? Say for example 0 can be expressed as 0 by, say for example 1. Now can we say multiplicative inverse of 0 by 1 is 1 by 0? 1 by 0 is not rational. So 0 does not have multiplicative inverse. 0 has no multiplicative inverse. Zero has no multiplicative inverse. Right. Next we will discuss rationalizing factor. Rationalizing factor. Say for example this number is irrational number. Now by what number this should be multiplied so that this becomes a rational number? You have to find a rational number. So how will you find a rational number? By multiplying square root of 2. Now you see square root of 2 multiplied by what number equal to rational? Square root of 2 multiplied by square root of 2 equal to square root of 4 means 2. That means square root of 2 is rationalizing factor of square root of 2. Right? Square root of 2 is a rationalizing factor of square root of 2. Multiplication of square root of 2 by another square root of 2, you got a rational number. Same thing you can find square root of 2 multiplied by, say for example square root of 8. You got square root of 16. This is rational. Therefore square root of 8 is a rationalizing factor of square root of 2. Similarly, say for example 3 plus square root of 2. By what number will multiply this to get a rational number? Now see, a plus b into a minus b. You already know this, a square minus b square. Product of these two factors is a square minus b square. Now consider this a plus b. So what is a minus b? 3 plus root 2. This is, if this is a plus b, then you can treat this as a minus b. Now a plus b into a minus b is a square minus b square. So this becomes 9 minus 2. This becomes 7, rational number. So what is the rationalizing factor of 3 plus root 2? 3 minus root 2 is rationalizing factor of 3 plus square root of 2, right? 3 plus square root of 2. Rationalizing factor of 3 plus square root of 2 is 3 minus square root of 2. Similarly, say for example, rationalizing factor of square root of 3 plus 5 is square root of 3 minus 5, right? I hope you understood these concepts. We'll discuss a few more examples in next class. So thank you for watching. Bye bye.